Hello everyone, in this video we are going to take a look at a conditional probability problems. Defective components. A lot of 11 components contains 3 that are defective. 2 components are drawn at random and tested. Let A be the event that the first component drawn is defective, and let B be the event that the second component drawn is defective. Now, write your answer as a fraction or a decimal rounded to 4 decimal places. Okay, so we know the fact that we have 11 components total. Okay, and 3 of them are defective. So we have 3 defective. If we have 3 defective, the other 8 should be non-defective, because the total is 11. 8 plus 3 is 11. They ask you for part A, P of A. This is the probability of getting event A. Event A is the event that the first component draw is defective. So now when I take out the first component, I want this one to be defective. I know that I'm looking for the probability. That means I'm looking for the ratio. We have 11 total, and you want the first event to be the one that is defective. That means we have 3 of them out of 11. So this is the ratio or the chance that you will get the first component to be defective. 3 out of 11 total. For part B, we are looking for P of B and then the vertical bar A. This is a conditional probability. So this is the same thing as asking you for the probability of event B given that event A has occurred. Okay, so we have a condition here. What is the probability of event B given the fact that event A has happened already? Okay, so event B, go back to the problem. Event B is the event that the second component draw is defective. Now I take out the second one. And this one is also defective. Okay, all right. So what is the chance that you will get the second component to be defective if the first component was a defective one? We have a total of 3 defective. After you pull out the first one, event A, it was defective. So inside the box, you only have 2 defective left. 2 of them left. And now you want the second component. When you take it out again for event B, you want that to be defective again. We took out one already. We got defective components. So in the box, we only have 2 more defective. So 2 out of 10, because we took out one. So 10, 11, we took out one, it became 10 components inside. And now the second time we take out another component, the chance that you will get that to be a defective one would be 2 out of 10 only, or 1/5. So 3 out of 11 and 1/5 for the other one. And then the next one, part C, we are looking for P of A and B. Okay, P of A and B. That means we want the probability of event A and also event B at the same time. So we want event A, which is the first component to be defective, and also the second component to be defective. So we want the first one to be defective. And then because of the and, we use the multiplication rule. And the first one is defective. And now we multiply to the probability of the second one, B, to be defective. But given the first one has already occurred, okay, because you have to base on whatever happened to the first one. We want both of them to be defective. Okay, so P of A, we got that earlier, 3 out of 11. And then P of B given A, which is the second part, 1 over 5. And that would be 3 out of 55. And then they ask you, the last part here, are A and B independent? The answer is no, they are not independent. And the reason is because if I take out the first component, if that first component is defective, then the second time when I take out another component, the chance that I will get another defective one is small, comparing to the case that the first one is not defective. Then the second one, when I take out another component, then that one has a higher chance to be the defective one.